Alright, Lewis structures today. More complicated ones.
Thank you. Right electron back to
Some of you will get to the point where you are so good at Lewis structures you only have to look at these steps. Yeah. But early on it might be helpful. Okay? So, all your notes are going to be is going over Lewis structures. So, let's start with. We'll go what?
So we're just doing Lewis structures. So there's not going to be like writing, like words.
Well, you could say, you know, you could put drawing Lewis structures, and then you could put. I'll give you an example, and we'll work through it.
Okay.
So there'll be no notes there.
Well, I would take notes, but it's not traditional notes. Does that make sense? Like I would show the process as we're doing it. What? Okay? So, we're going to start with Ni3.
I know it.
Okay? This guy we are going to do. Okay?
Wait, isn't there an Ni and then that's the actual right?
Yeah, it's different. This is
Yeah.
nitrogen bonded with 3 iodines. It's not nickel. Okay?
Oh, that's
So, very first step says to write the electron dot symbol for each. The reason that I don't have to do all 3 iodines yet, but the purpose for this is to identify how many bonding sites there are. Okay, how many valence electrons does the nitrogen have? Everybody?
5.
5.
Okay, and iodine?
Iodine has 7.
Right. The reason why we just kind of do that, you might be able to not have to write them down to figure out how many bonding sites there are. You might just be able to do it in your head. But if you can't, then just write them down to see how many bonding sites there are. Okay, so number 2 says, place the element with the largest number of unpaired electrons in the center of your Lewis structure. You could also reword that and say the one with the most bonding sites. Does that make sense? What I'm asking? Which of these 2 has the most bonding sites or is the most unpaired electrons? Nitrogen. So, nitrogen is going to go in the middle of your Lewis structure. So let's just write nitrogen with the number of valence electrons it has. Okay, number 3 then says, place the remaining elements around the central atom. Well, what are my remaining elements? How many of them? 3. Now, listen very carefully. Remember the unpaired electrons represent bonding sites, which just means that's where they're going to bond, correct? Okay? So, I'm probably going to put my 3 iodines next to the unpaired because there's going to be bonding going on, right? I'm probably not going to put it up here because this isn't a bonding site. You're never going to touch or mess with the guys that are already paired. That make sense? Now notice, when I write this iodine, I put my lone pairs away and I put my bonding site towards the bonding site of nitrogen. That makes sense, right? I'm going to do that for all of these. I would strongly suggest that you use a pencil when doing Lewis structures. You're not using a pencil, are you?
Well, not for this, but I will.
Okay? I strongly suggest using pencils because you're going to have to do some erasing and changing stuff. Okay? Now what you're looking for is, remember, we put dashes that represent a covalent bond, correct? And a covalent bond means how many electrons? 2. 1 electron from each thing that's being shared. So when you form a bond, if you look here, I have a bonding site here, a bonding site here. If I remove 1 electron from each, I can put a dash. So that we're now beginning number, where are we, 4? Create single bonds where possible. What can form here? Another single bond. But remember, every time you form a dash, you better remove 2 electrons. Does that make sense?
Yes.
Because the dash represents 2 electrons. You can't have a dash and also have those electrons there. That's a problem. Okay? Now, number 5, it does say create double bonds or triple bonds if you need them. Do we need them?
No.
No. Okay, so let's go back and let's look at 6 then. Let's check to make sure we have done this correctly. It says check to see if all your elements fulfill the octet rule. Okay, well let's look at iodine. 2, 4, 6,
8.
2, 4, 6,
8. 8.
2,
4, 6, 8.
Whoa.
If that's correct, you've probably done it right. Okay, another thing you should be looking for, is there any more unpaired electrons up here?
No.
No. If there were still unpaired electrons, I'm guessing you've done something wrong. Okay?
Right.
Make sense?
Yes.
Alright, this one wasn't the more challenging one. We'll get to some more challenging ones as we progress.
Yay.
Question?
No.
No? Alright.
That's not an O.
Ooh.
Oh, fancy.
Oh, okay.
Fancy, so that's. Oh, that's what us do.
Y'all ready?
Yes.
Okay. Who can identify the central atom without even writing it down? Silicon.
Yep.
Okay? But here's how you would look at it. Silicon has 4 valence electrons. Wouldn't that mean you'd have 4 unbonded electrons?
Yes.
Oxygen has 6. That means you have 2 unbonded. And chlorine has 7, meaning 1 unbonded. Does that make sense? Now, if you can't do that in your head, write it down and see it. Okay? Silicon is my central atom. Alright, then put all the other guys around it. There's 4 locations, but we only have 3 elements. That's okay. Now, you're probably wondering, well, where do I put the chlorines and where do I put the oxygens? The answer is it doesn't matter. I can put the oxygen here, 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 or here. Doesn't matter. We'll put the chlorines here, 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 here. Doesn't matter. Okay, so I'm just going to choose to put the oxygen here. It has 6 valence electrons. Everyone Gucci with that?
Yes.
Again, I put bonding sites toward bonding sites as best I could. You don't see me putting paired electrons toward paired electrons. Okay? Now, form single bonds where we can. Just start with single bonds. Right here? Right here? Right here.
Yes.
Now, to figure out if you have to put a double bond or triple bond, you need to go look and see if things are stable. If everything's stable, do you need any more other bonds if everything's stable?
No.
No, but in this case, if we look, these 2 are stable, right? 2, 4, 6, 8. 2, 4, 6, 8. Chlorines are good. Don't touch them anymore. But is silicon stable?
No.
2, 4, 6, 7. 2, 4, 6, 7. Which means I have 2 guys that aren't stable. And do you notice how I still have a bonding site on both of these guys? So what do you think is going to happen?
Raise the electrons inside.
They're going to form a double bond. Now remember, you don't do this and like connect them like that. Remember? Take them away and put them where? Not too bad, is it?
No.
Sometimes kids think these are awful. Now, there's some harder ones when you take upper level classes, but we'll start with these. Okay? Let's check to make sure silicon and oxygen are stable. 2, 4, 6, 8. 2, 4, 6, 8. We good?
Yeah.
Yes, sir. Vanilla. Any questions so far?
No.
After I erase that?
No.
Vanilla. Okay. We can tell what the central atom is. Silicon. Am I going too fast? You guys trying to do it yourself here or what? Want me to let you try to do it yourself? Why don't you try? That chain. Yeah? Anybody not get this? Now, I did something goofy with these guys. You notice what I did? I didn't put them north, south, east, and west, did I?
No.
Here's why I didn't do that. These are electrons, right?
Yeah.
Don't these electrons repel these electrons?
Yeah.
So I want to have kind of the angle between all of them the same. Because they repel each other, right? If I were to keep it like this, you see how this is a much bigger angle than that is and that is? Okay, now I'm not requiring you to do that. I'm just showing you why I do that. Okay, I make my chemistry kids do that, but I'm not overly concerned if you do that. Okay, on the previous one too, just showing you another way how I did the previous one. I show the previous, it's silicon, right? I show it like this. Was it hydrogen or chlorine or what was it?
Chlorine.
So the reason why I show it like this is for the same reason. Don't all of these repel each other? So I want them to be approximately the same angle. Again, I'm not going to make you do that. I'm just telling you that's kind of the next level. Okay? Anybody not get this? It's okay. I want to go through the process if you didn't get it. It's okay. I promise you. I don't want you to be worried that I'm the only one who didn't get it, because there's a lot of things I don't get. So, cool? All right. Let's see. What next? Let's do one that's doesn't have a one central atom. This one I might need to show you. Okay? How about if I give you this hint? I'll give you a hint. There are two central atoms. And it's a yeah, that doesn't help? Okay, I'll go through it. I'm going to put my two central atoms next to each other. Okay? Like so. Then I have a decision to make. I've got two fluorines, correct? I can put the two fluorines here. I can put the two fluorines here. Or I can put the two fluorines here. We have to figure out which one is the best way to do it. Okay, I'm going to tell you which one's the correct way to do it, but then I want to show you why the other way is not okay, why it won't work. Yep.
That's the way I do it.
What's the way you do that?
That's the way I said
You set it up just like that? That's good. Okay, single bonds. Let's start with the easy single bonds. Which ones are the easy single bonds?
The ones do easy.
These ones, right?
Or yeah.
Because we know fluorine isn't going to have any more bonds than one, right? Because it only needs one more to be stable. So we'll go like that. Then we'll go like that. Now, always step back and look at it and go, okay, are there anything stable? What's not stable? What's stable? Anything up here stable?
Yeah.
What?
The two.
The fluorines are stable. Is there anything up here not stable?
Yes.
What isn't stable?
The orange phosphorus.
Alright, if these aren't stable, you're going to have to form some more bonds.
Yeah.
Okay? Well, let's just start with a single bond. Which means I'm removing one from each, forming a single bond. That looks like pretty easy to do here, right?
Yeah.
But am I stable now?
No.
2, 4, 6, 7. But notice each of them still has one bonding site or one lone or one unpaired electron each. In this case, what would I form? Now if we count, we should have 8 around everything. 2, 4, 6, 8. 2, 4, 6, 8. Capiche? Wow, man, I feel like this class I don't even have to go through anything else.
Nope.
I know I'll have to take 2 days to do this in the main period though.
Yep.
So we're going to take today and tomorrow doing these. But I'm going to give you just a few easier ones that you can work on. We'll do some more difficult ones tomorrow, or I'll make you do some more difficult ones tomorrow. Okay? Let's see, I want you to do that's 4 chlorines, not carbon, and L. Not that, and